You believe you have a grasp on time. You look at your watch. You feel the slow march of aging. You recall what you did yesterday and make plans for tomorrow. Time feels intuitive, doesn't it? Like the most basic, fundamental aspect of our existence. But what you're experiencing isn't really time. It's a sensation, a clever illusion crafted by your own brain. Many of us hold on to a poetic but deeply flawed idea that time is a river. We imagine it flowing, carrying us from the past, through the present, and into the future. It's a lovely image, but it has a huge problem. If time is a river, how fast is it flowing, 1 second per second? That statement is completely meaningless. It's like saying your desk is 1 desk long. It tells you nothing about the true nature of reality. The truth is far stranger, much more mechanical, and frankly a lot less romantic than a flowing river. Time doesn't flow. It doesn't push you anywhere. And if you think you understand how time works just because you can count the seconds, you're in for a shock. Let's start with what happens inside your own head, because that's where all the confusion begins. You think your internal clock is a precise instrument. It's not. It's a chaotic jumble of different mental strategies. Think about this. Try to count to 60 seconds in your mind. Just sit quietly and count 1, 2, 3. You think you're tracking time, but what you're actually doing is running a very personal, very specific mental program. For some of you, as you count, you hear a little voice in your head. You're literally talking to yourself, subvocalizing the numbers. If someone interrupts you and makes you speak, your count is immediately lost. The mental machinery gets jammed. But for others, and this is where it gets really interesting, there's no voice at all. Instead, they see images. They might visualize a measuring tape with numbers clicking past, like an old-fashioned ticker tape. Click, click, click. If you use that visual system, you can actually read an article or look at a shopping list while you count time. You can sort your laundry, notice the patterns in the fabric, and still keep that mental tape measure ticking along perfectly. But the person who counts with an inner voice? They can't read a single word without losing their place. This reveals something profound. What you experience as the passage of time is just a mental model, a pattern-matching game your brain is playing. It's completely different from person to person. It is not some universal, objective reality. It's a biological hallucination. So, when we want to talk about physics, when we want to talk about the universe, we have to throw your brain's perception out the window. We must stop talking about how time feels, and start talking about what it actually is. In physics, we have to be operational. That means we don't ask, what is the essence of time? That's a question for philosophers to debate over coffee. Instead, we ask, how do we measure it? And the answer is almost disappointingly simple. Time is just a way of ordering events. That's it. It's a labeling system. Imagine you have a deck of cards laid out in a row. You can say the jack comes before the queen, and the king comes after the queen. The cards aren't moving. The table isn't flowing. The order is just a structural property of how the cards are arranged. In this analogy, time is the table, and events are the cards. When we say time passes, we're just reading the cards from left to right. This brings us to the biggest mistake most people make. You think of time as a container. You imagine the universe as a big, empty box, and time is a clock on the wall of that box, ticking away independently. You believe that even if we removed all the stars, all the planets, all the atoms and all the light, that clock would keep on ticking. Tick, tock, tick. That's completely wrong. This is the old Newtonian view, and it's been obsolete for over a century. Time is not a background stage. Time is a measure of change. If absolutely nothing in the universe changed, no atoms vibrating, no light moving, no energy shifting, then time would stop. It would cease to have any meaning. You cannot define a second without a physical process to mark it. A swinging pendulum, a vibrating quartz crystal, an oscillating cesium atom. Time is not separate from the stuff in the universe. Time is a property of the stuff. This is where your intuition starts to fight back. You might say, but wait, time acts on things. Time makes me get older. Time causes the milk to go bad. No, it doesn't. This is a trap built into our language. Time is not an agent. Time doesn't have hands. It doesn't reach into your fridge and spoil your milk. Bacteria do that. Chemical reactions do that. The laws of thermodynamics do that. Time is just the bookkeeping system we use to track the rate at which those processes happen. Saying time did it is like saying inches built the house. Inches didn't build anything. Carpenters did. Inches just tell you where to put the walls. Time is the ruler, not the worker. Let's push this ruler analogy further, because this is where things get truly mind-bending. If time is just a ruler we use to measure the distance between events, what happens if the ruler itself is flexible? This isn't science fiction. This is a measurable, verified fact of our universe. We used to think a second on Earth was the same as a second on Mars, that clocks everywhere would tick in perfect unison. It feels obvious, it feels right. And it is completely false. The rate at which clocks tick depends on two things: their position in a gravitational field and how fast they are moving. This isn't a mechanical flaw in the clock, it's a fundamental feature of reality itself. Imagine you're driving a car on a massive, flat sheet of paper. You can drive north or you can drive east. If you drive purely north, you make maximum progress in that direction. But if you turn the wheel and start driving northeast, you are now splitting your speed. You're moving a little bit north and a little bit east. You're no longer going north as fast as you were before because you diverted some of that motion eastward. Now, replace north with time and east with space. This is the core of Einstein's relativity. Everything in the universe is constantly moving through a unified fabric called spacetime, and you're always traveling through it at one constant speed, the speed of light. If you are sitting perfectly still in your chair, you are dedicating all of your motion to traveling through the time dimension. You are hurtling into the future at the maximum possible rate, 1 second per second. But the moment you stand up and walk, or get in a rocket and fly, you are diverting some of that motion into the dimensions of space. Because you are now moving through space, you must move slower through time. Your personal clock slows down. Your aging process slows down. You aren't breaking the laws of physics, you're just changing your direction on the four-dimensional map of reality. If you could travel at the speed of light, you would be using 100% of your motion for space. You would have zero motion left for time. For a photon of light, time does not pass at all. From its own perspective, it is emitted and absorbed in the very same instant. The entire history of the universe is frozen into a single moment. Now, you're probably thinking, well, my watch doesn't slow down when I run to catch the bus. And you're right. You're just too slow. At everyday human speeds, these effects are infinitesimally small. But they are real, and we have to account for them. The satellites that make up our GPS network are moving very fast and are in a weaker gravitational field than we are. Their time runs at a different rate from your time. We literally have to program their clocks with Einstein's equations. If we didn't, your GPS would be off by several miles within a single day. There's another aspect of time that tricks us, and it brings us back to that mental counting problem. The idea of pattern recognition. We perceive time as having a clear direction, an arrow. The past is fixed and unchangeable, while the future is open and full of possibilities. You can remember what you had for breakfast, but you can't remember what you'll have for dinner. Why is that? If the fundamental laws of physics work just as well forwards as they do backwards, and most of them do, why can't we remember the future? If you film a planet orbiting a star and play the footage backward, it looks perfectly normal. It still obeys all the laws of gravity. But if you film an egg falling off a table and smashing on the floor, and then you play that backward, everyone knows it's fake. The shattered pieces of shell and yolk don't magically leap off the floor, reassemble themselves into a perfect oval, and fly back onto the table. Here's the secret. The arrow of time isn't about time itself, it's about probability. It's about disorder. It is vastly, overwhelmingly more probable for an egg to be in a broken state than a whole one. There are billions of ways for an egg to be broken, splattered here, scattered there, shell in 3 pieces or 1,000. But there is only one specific highly ordered arrangement where the egg is whole. As things in the universe move and interact, they naturally and randomly stumble from organized states, which have few options, into disorganized states which have many options. We call this universal tendency toward disorder entropy. And the increase of entropy is the only reason you feel an arrow of time. You're watching the universe constantly shuffle a deck of cards. It started in a perfectly ordered state, and every second that ticks by is just the universe shuffling it a little bit more. You can't unshuffle the deck just by wishing for it. This means your very sensation of time flowing is actually just your brain registering the relentless increase of messiness in the universe around you. You are a disorder detector. When you distinguish the past from the future, you're really just distinguishing a less messy state from a more messy one. If the universe ever reached a state of maximum mess, maximum entropy, where everything was perfectly uniform and nothing interesting was happening, your brain wouldn't be able to tell the past from the future. There would be no egg to break. There would be no memory to form. In a universe at thermal equilibrium, the arrow of time would simply vanish. So let S return to those people counting in their heads, the ones seeing the tape measure versus the ones hearing the voice. They are both trying to impose a rigid, linear structure onto a universe that is actually much more flexible and complex. We build these mental models, these internal counting machines, because they are essential for our survival. We need to know when the sun will set or when the crops will be ready for harvest. We evolved to track duration, but we did not evolve to understand the true, four-dimensional nature of time. Our brains are built for efficiency, not for cosmological accuracy. We focus intensely on the now because that's where we live and make decisions. But in physics, now is a very slippery concept. If you and I are standing next to each other, our now is effectively the same. But if you were on a planet a million light years away and you started walking towards me, your definition of now would slice through the fabric of the universe at a slightly different angle than mine. What you consider to be happening right now on Earth could be hours in my past. There is no single, universal now that covers the entire cosmos like a blanket. The universe is a block of events, a four-dimensional loaf of space-time. And how you slice that loaf to define your present moment depends entirely on how you're moving. This is hard to grasp. It feels fundamentally wrong, like I'm telling you that up is down. But that's because you are trying to translate the high-level language of the universe into the low-level language of your biology. You are trying to count seconds with your internal voice when you should be measuring the curvature of space-time. When you try to force the universe to fit your intuition, you get paradoxes and confusion. But when you let go of what you think time is, when you stop trying to count it and start measuring it as a dimension, suddenly the equations work. Suddenly the universe makes a strange and beautiful kind of sense. But we're not done yet. Even if we accept that time is a flexible dimension and that its passage is linked to disorder, there's a much deeper question lurking. We've talked about measuring time and its arrow, but we haven't talked about its beginning. If time is a measure of change, what happens when you run the movie of the universe all the way backward to the very first frame? We know the universe is expanding. If we rewind that expansion, everything gets smaller, denser, and hotter. Eventually, you hit a point of infinite density where our current laws of physics simply break down. We call this moment the Big Bang. All of our clocks, our atoms, our pendulums, our light beams exist inside the universe. But if the universe itself was born in that singular moment, does it even make sense to ask what happened before the Big Bang? This is the ultimate test of our new understanding of time. If time is just a system for ordering events within the universe, then asking what came before the universe might be as nonsensical as asking, what is north of the North Pole?